What's up guys, Kelvin here, and today we're looking at a packet tracer lab which is taken from the Cisco Netacad material, and it's lab 5.1.5.7 configuring OSPF advanced features. Now I wanted to run through this lab particularly because I'm nearing the deadline to my CCNA certification exam, so I'm just kind of covering a few topics to kind of get everything in my head again, make sure I've covered all bases. So for those that are still learning and maybe new to OSPF or the more advanced features within OSPF, this lab will be perfect for you. So for those that are not on Netacad, you can design this topology and follow it through, or you could just watch and have a look what I'm doing. So we're going to start by running through this topology. We have a completion bar here at the bottom, 0 out of 100% so far because we just started it. However, our main aim is to get 100 out of 100 for that. So step one, we're going to begin by testing connectivity between all end devices. So what we'll do is from each of these PCs we'll ping the web server. Okay, so if we just do a ping 64.100.1.2, first one should time out, but we'll just run that again to make sure that all 4 replies come through. There we go. That's fine on that one. So we'll move to PC 3, and again ping 64.100.1.2. there we go, that's fine. And last but not least, PC 2, and we'll do a ping 64.100.1.2. Great stuff. So we know that we do have connectivity, which is all good. So we're going to move on to step 2, and we're going to adjust the LO and dead timers between router 1 and router 2. So this link here. So we've been given the interface, which will be that interface serial 000. So we're going to go ahead and do that now. But before I do that, for those that are new to OSPF, the LO and the dead timers, they need to, whatever the LO timer is, it needs to be times 4. So the default LO timer is 10. So the dead timer is 40. So whatever you change it to, you need to make sure there's that difference there, or it won't function correctly. Now what we're going to do on here is we're going to change the hello and the dead timers on the serial 00 interface connecting to router 2, and this link is going to end up going down because the LO and the dead timer on router 1 is different to the LO and dead timer on router 2's interface, which connects to router 1. Now again, the LO and dead timers on each interface need to be the same as the connecting interface, or the adjacency will go down. So we'll just have a look at the show IP OSPF interface serial 00. We'll just have a look at the default timers, and there we go. So the default timer there is 10, and 10 is 10 seconds, and the dead timer is 40 seconds. Okay, so we'll do a show IP OSPF neighbor, and serial 000, that's that interface. We can see that the dead timer is functioning correctly at 40, and what this does is it counts down, and I think it goes to 30 before starting again at 39 and goes down. So that's like the 10 seconds. So what we can do is we can actually observe that by, if we just do this a few times, this show command, 37, 35, 34, 33, 32, 31, 30. Should go back up now to 39, and there you go. So that's what the LO and the dead timer is pretty much all about. Okay. So again, what we'll do is we'll change the LO and the dead timer, and we will observe and see the LO and the dead timers go down. Okay. Let me just have a look here. Yep, that's fine. Yep. So we'll go ahead and we will change that LO and dead timer now. So we'll jump into the interface and we'll do an IP OSPF LO interval, and we're changing that to 15 seconds. Now you can up arrow and you can change. Remember what I said about being 4 times whatever your LO is? So it'll be 15, 15, 15, 15, which is 60. And we just changed that LO bit there to dead and enter. And just before I press enter on this, we're going to shoot back to privileged exec mode, and we're going to observe the dead timer again. And the dead timer will drop below 30, and the adjacency it'll count down to 0, and that's when the process will drop. Oh, I think it's done already. Wait a minute. Did I enter that? Yeah, I did the LO, so it's already counted itself down. So I'll tell you what we'll do. Instead of, I'll do a no IP OSPF LO 15. So that'll put it back to the default. And we'll just let that adjacency form again, and we'll do it right there. We go. It's formed again. So we'll do it right quick, and we'll see the countdown before the adjacency goes down. Okay, so we'll change the LO real quick, and we'll change the dead timer real quick. So that's LO, and we'll change the dead. So that's the dead, and we'll do show IP OSPF neighbor. So as you can see, it's already counting down 18, 17, 15, 14, 13. So we'll follow it all the way down till it gets to the bottom, then the adjacency will go down. 7, 6, 5, 4, 3, 2, 1. Adjacency should go down. There we go. That's it. Adjacency's gone down. And as I said before, the reason that's happened is because Router 2's interface is different LO and dead timers. And if you are looking at taking the certification exams, this is definitely something I believe you need to know. Okay, so we've done that now, and we know that we don't have an adjacency now. After a short period of time, the OSPF connection with Router 2 will fail, which it just does. Both sides of the connection need to have the same timers in order for the adjacency to be maintained. Adjust the timers on Router 2. So what we're going to do is we'll jump on Router 2. We'll just check that interface, so it's the same. And we will put the LO and dead timers the same as what we've just changed them to on Router 1 with the same commands. IP OSPF LO interval, and it's 15 seconds. IP OSPF dead interval, and it's 60 seconds. And that adjacency should form again in a minute. We'll just give it a few seconds. And there we go, that adjacency is formed again now because the LO and the dead timers are the same. So we'll do show IP OSPF neighbor, and we can see there that we have the neighbor adjacencies formed nicely. So that's great stuff. And if you look at the dead timers, because the other interface on Router 2 is using the default dead timers and LO timers, but we've changed that one now to use a different dead timer, 60 seconds. Okay, so we'll just have a look at that. 52, 51, 50, 49, 48, 47, 45, 59 again, because that's the 15-second window. Okay, so we know that that works now. So where's my, there we go. So we'll move on to step 3, and we're going to adjust the bandwidth setting on router 1. So we're going to trace the path between PC1 and the web server located at 64.100.1.2. Notice that the path from PC1 to the web server is routed through router 2. OSPF prefers lower cost paths. Okay, that's a key thing to remember. Prefers the lower cost path. And it's kind of in the OSPF name really, open shortest path first. So on router 1, serial interface at 000, set the bandwidth to 64 kilobits per second. This does not change the actual port speed, only the metric that the OSPF process on router 1 will use to calculate best routes. Okay, so we'll do that now. So we'll do conft interface serial 000, and we'll do a bandwidth to, we'll just question mark that and have a look so you can see what options you have, and you only have the option to enter the 64, is it? Let me just double check. Yep, 64, which we're entering. So we'll do that now, which is done. So as it says there again, it don't change the actual port speed, only the metric that OSPF uses to calculate the best routes. So we've just messed up that metric a little bit now. So what we're going to do is we're going to trace the path between PC1 and the web server again. Notice that the path from PC1 to the server is redirected through router 3 because this link. OSPF prefers the lower cost path. So I'll tell you what we'll do. Before we do that, we'll actually conft interface serial 000, no bandwidth 64. We'll trace the path first so we can see the route it does take first before we change the bandwidth, and we'll also look at the default bandwidth. So we'll do show interface 000. So bandwidth there, so 1544. Okay, so we change that to 64 after. So what we'll do is we'll trace this route now to this web server here. The route should take this path, so from router 1 to router 2 to the web server. So we'll do a trace RT 64.100.1.2. So we can see that it's hopped to 16.1.1, and what we'll do as well, we'll bring these up side by side, in fact, just for more clarity. So we'll do a show IP route. Wait a minute, wrong one. There we go. So we'll put these side by side. So we're looking at 172.16.1.1, which is directly connected to gigabit Ethernet 00, which is going to be here. Then the next hop is 172.16.3.2. Okay, so we know that there we go. We know that this is directly connected as well, 172.16.3.1. So that's this interface here, but it's not going to count that interface. It counts the next hop because the interface it entered was gigabit 00. So the next hop is the 172.16.3.2, as it mentions here. Then it goes to 209.165.200.226. Okay, have we got a route? No, we won't. So the next route it takes, obviously we know it's got to, we'll just minimize that a minute. We know it's got to router 2 now. So the path it's taking now is 209.165.200.226. So if that's a subnet 224, then I'm guessing this link here is going to be 225, and this next hop to the internet is 226. Then it arrives at the actual web server, which with the address there. So we've pretty much just traced that route through, and I've talked you through it. So we know that OSPF is choosing from router 1 to router 2 to get to the web server. Now we're going to change this bandwidth on router 1. Then we're going to observe and see what path it takes now. Okay, so we'll do a conft interface. What interface are we using here? 000. No, we're going to change the bandwidth, sorry, on the route connected to router 2. So 0000, and we'll do bandwidth like we did before, 64 kilobits. Okay, so that's that done. We'll verify that with the show interface 0000, and we can see now the BW, which is bandwidth, has changed to 64. Okay, now if we do a show interface 0001, which is this interface, we can see that the bandwidth is higher. Okay, so that's obviously better. So again, we're going to trace the route from PC1 to the web server, and we'll see what we get now. Notice here that this was the last route that we traced. Notice how this will change. The first stop should stay the same because that's the entrance interface here. Then it won't be hopping to 3.2, which will be here. It'll hop to, let me guess this, for 192.168.10.6. So we'll see that, then we'll see where it goes from there. So it'll go actually a longer way around, if you like. So we'll do this now. There we go. So as we see, as I said, we've got the 172.16.1.1 as we did there, but it's not going to 3.2 now. It's going to 10.6, so I was right. Then it goes to, from router 3, it'll jump to 3.2, wait a minute, 10.6, 172, yeah, 3.2. It'll jump to that interface. Then from there, so from router 2, then it'll go to the internet as it did. Then it goes direct to the web server. So we can see there we had 4 hops to get to the server. Now we've got 5 hops to get to the server, which is longer, which is not good, but the bandwidth on that line is at the minute rubbish. So we've got to this part now. We'll see what it's asking us to do now. We've traced the path. Okay, so we go to enable OSPF authentication. No, it's the path. Yeah, we've done that. Yep, OSPF prefers the lower cost path. Okay. Use the following commands to configure authentication. So what we're going to do is we're going to leave the bandwidth like that by the looks of it. and we're going to configure authentication on router 1 and 2. Okay. Okay, so I believe between router 1 and 2, so we're going to start with router 1. We'll just pull this up here so I can go through it with you guys. So we're going to go to, by the looks of it, the OSPF process. So we'll have a look, show IP OSPF. So we can see the process ID is 1. So we'll do a global config router OSPF 1. Nearly forgot how I'm doing then. And we'll do an area 0 authentication message digest. In fact, before we do that, we'll just do a question mark. So the message digest is use message digest authentication, which we'll go through more in detail. You create the keys on the interface, so we'll do that. Okay, now we'll exit out of that and we'll jump on serial 000 interface connecting to router 2, and we're going to do an IP OSPF message digest key of 1 MD5 hashing, and the case sensitive key is R1 and R2. Remember what I said, case sensitive, you need to make sure whatever key you write in it is, you know, you can bear in mind it is case sensitive. At the minute the OSPF adjacency has gone down because we've set up authentication, however we've not authenticated anything yet. So that's the key we're creating there, that's the message digest key on the interface. So we'll go ahead and we'll enter that. And we've already lost the adjacency, so we're going to do the same commands on router 2. So we'll just exit out of that for now. We'll jump on router 2. Again, in fact, we'll do show IP OSPF process ID 1. So we'll do router OSPF 1. We're doing it on, yeah, we are doing it on that one. So we'll do area 0, want it, yep, area 0, which is backbone area. Authentication message digest. Then we'll jump into the, just make sure it's the same interface. Yep, serial 000, so router 2. There we go. Interface serial 000, IP OSPF message digest key 1 MD5 case sensitive again, remember, R1 R2. So this is gonna map now and the adjacency should form once I press enter. So we'll do this now and we'll see if that happens, hopefully. We'll just give it a second. There we go, loading done. So that adjacency is back now and it's everything's been authenticated. So that's OSPF authentication on one link. So let's move on. Use the following commands to configure authentication on router 1 for the link that shares with R3. Okay, notice how the digest key is R1 to router 3 instead now. Okay. So we shall do that now. We don't need router 2 for now. We'll jump back on router 1. And we'll do interface 0000. And we will do IP OSPF. I'm just trying to think. Will we? No, we'll go ahead. Message digest key 1 MD5, and we're doing R1 to R3 this time. Now that adjacency should go down once I message digest key. So we've done that. So. And we just refer to these instructions in a minute. So yeah, we are doing it. Yeah, so we are doing it with the same link. Yeah, that's fine. So what we need to do then is we need to jump on to router 3 and do the same. We'll need to do the OSPF authentication, in fact. Okay, so what we'll do, jump onto router 3. EN show IP OSPF process ID 1, so we'll do conft router OSPF 1 area 0 authentication message digest exit, and we'll just, I need to know what interface I'm working with, so we'll do a come out of that, show IP interface brief. So we are working with 10.4, so we're working with serial 000 interface serial 000, and we're going to do IP OSPF message digest key 1 MD5, and it is R1 to R3. So that should be right. So we'll just, yeah, there we go. So we've had the adjacency form now, which is good. So we'll verify authentication is working between each router. So we'll do that with a show IP OSPF interface, or int. And where we're looking here, there we go. Message digest authentication enabled, so this is for router 3. Yep, so that's fine. That's the actual serial interface. So we'll jump on to router 1. We've already got the adjacency there as well. Show IP OSPF interface, and we'll look at both serial interfaces. So we've got one here, and we have one there. So that's good news. So we'll verify the connectivity. In fact, finish the authentication configuration necessary to restore full connection. The password for the link between router 2 and 3. So we actually need to do router 2 and 3 as well. So we're missing. So we'll move back on to router 3 and we'll just have a look at the interface we're using. Yep, so that's 10.81.00. So we'll go to conft interface 0001 and we'll do IP OSPF message digest key 1 MD5, and we're doing let me just double check before I enter a key. We are doing on router 3. So we're doing R2 to R3. Okay, so R2 R3, enter. So now we'll jump onto router 2 and we'll jump onto 0001 and we'll exit out that interface 0001 and we'll do IP OSPF message digest key 1 MD5, and we're doing router 2 to router 3, and that adjacency has formed again, which is good news. So we're going to verify all PCs can ping the web server and each other, so that's good. Loading's fully done. We have a completion rate of 100 out of 100. So what we'll do is we'll just verify connectivity, and that's that lab done. I hope it's been informative. I have shown you a little bit more with how the hello and the dead timers operate, etc. But that's part of learning. So I hope you enjoyed that bit. So ping 64.100.1.2, that's working, which is great. PC 3, that's working, which is great. PC 2, they're all working, which is good. So that's that lab over. I hope you enjoyed it. Thanks for watching.